Hello everybody, I am Sudhir Vagunhari, the Managing Director of Shriyash Electromedicals. We are into manufacturing newborn life-saving devices since 1990, and we make various newborn life-saving devices like the baby incubators, servo control and non-servo control mode, the radiant heat warmers, often known as the open care system or the open care incubator, that the phototherapy system using a conventional tube-like technology, and now we have added into it the LED technology, which has been clinically proved that is much more effective than the conventional one. Plus then we have the Aquatherm bubble CPAP, the neonatal and pediatric conventional ventilator with 7 different modes of ventilation, and above all, the high-frequency oscillatory ventilator, the only servo-controlled high-frequency oscillator in the world, which is popularly known as the Dragonfly. Okay, we are an ISO 9001-2000 company registered, and the process and manufacturing is done as per the norms of the ISO 9001-2000. Plus, we have an ISO 13485. For our achievements in this field, we have received several government awards from Government of India, like the best industry in the year 2000, the best product in the year 2002, so on and so forth. Plus, we are also certified by the CE marking, and hence now all our products are internationally available. Now, to tell you more about our product, I take you directly to the products and explain the product to you in brief. You can see behind me. Can please come forward? You can just see behind me the open care incubator as a very popular model known as a Jiva Basic 3. I suppose it's the best ventilator, the best warmer available in the market, in the international as well as the international market, due to various reasons. First and foremost thing, if you see, it is diligently designed. For example, see the features like the rotating monitor trays. You will not see anywhere in the world. And this is done this increases the efficacy of the infant caretaker. For example, we can keep an pulse oximeter here. We can keep an infusion pump here. While working, if the clinician feels that something is an hindrance to him, he can just simply rotate this tray and bring it to the other side. Don't you think that's unique? Have you seen it ever? Plus, secondly, a very small innovation I would like to tell you, a very small innovation. Normally, we have in the saline stand, through which we give the IV drip, or either the one left or the right side of the worm. Normally what happens, if you have to shift the saline to the saline line from the baby's left side to the right side, what all you need is that the entire saline line crosses over the baby. In this thing, in a Jiva warmer, what you can do is that you can just rotate the saline stand either to the left of the machine or to the right of the machine. You can see. Plus, if you go to the smaller features like the heating device, see, we have not used a traditional heating coil system. The traditional heating coil system, what happens in that after a certain period of time, due to humidity, it gets deoxidized and the coil breaks. So you need to service the warmer. Here what we have done here is that we have used a concealed ceramic heater, which is again a CE certified component. So it's much more effective as compared to the conventional infrared quartz heater. The energy efficiency transmission is 96% as compared to 60% of an infrared quartz heater. Secondly, if you look at the temperature control mechanism, it's so beautifully designed. So you have a lot of things incorporated in this, like a feed alarm. After each 2 hours, you get automatically an alarm is generated to warn the nursing staff regarding the feed schedule of the baby. It's a minor thing, but then, my friend, it makes a lot of difference. Plus, you have an ABGAR time. So when this open care system is placed in a delivery room, immediately after the birth of the baby, once you press the ABGAR time score, it gives you an alarm after 1, 3, 5, 7 and 10 minutes, so that the clinician can perform all the required things in the stipulated period. Coming to the heating control mechanism, is a totally servo-controlled heating system. Here you can set what is the required temperature for the baby And here it is displaying what the temperature achieved by the baby, what the baby's body temperature achieved. Plus, you can see the baby's temperature in degrees centigrade as well as in degrees Fahrenheit. Just have a look here. See. Now it's degrees Fahrenheit. Press this, a small button, it goes to degrees centigrade. See. Plus, you have a proportional system. Initially only the heater consumes 100% of the power. But as the baby's temperature starts reaching the desired level, the power to the heater is reduced down proportionally. So it achieves two things. One, it saves your electricity. Two, it ensures that the baby's body temperature is maintained very precisely and is absolutely safe for the infant. Plus, you have another mode of control. You have either a manual mode or a servo mode. In case of an emergency, if you have to warm the baby very fast, just press this manual mode. Automatically you can see the temperature set has gone now to 37 degrees centigrade. Initially it was on a servo mode, I had set the temperature at 35, but once I press this manual mode, you can see the temperature has gone to 37 degrees. So now what happens? The heater now works at full power, quickly warming the infant, and as the baby's body temperature reaches 37 degrees centigrade, it automatically, my friend, shifts from the manual mode to the servo control mode. And that's the beauty of this machine. Plus you have all the safety alarms like the high temperature, the sensor failure, and the low temperature alarm, the sensor, the power failure alarm, and all those things. Plus, now again a small innovation. If you look at this observation lamp, this is a clear crystal white observation lamp. Normally, in the old days, people used to use the halogen type, which used to emit the yellowish type of lamp. But now this white lamp, it's helped the clinician to diagnose the patient's color very effectively. Now, again, this heater box rotates around its axis for a trouble-free X-ray procedures. You can just take it on the side, either side of the machine. Now, after that, we have an X-ray cassette placed here under the baby's bed. You can just roll it. You can just bring it outside. You have an X marking plate marking there. So the zero marking is in the center. So now you just place your X-ray plate, push it inside, rotate the heater box, bring an X-ray machine, and take an X-ray of the baby. As simple as that. Now, coming to the baby area, it's a large, soft cushion baby area where the baby can be comfortably placed. This is the sensing device that senses the baby's body temperature. It's a specially made skin temperature probe. And mind you, it's not disposable, it's reusable. It has a 4 cable inside it, that's why it makes it very tougher. Plus, if you see the diameter, if you see the shape of this sensor, from the top side, you have the materials that are bad conductor for heat. So it doesn't send this heat from top side. But if you see the other side, which is fixed to the baby's abdomen, it is large in diameter. Plus it is plated in silver. So the sensitivity is increased. So my friend, this smaller innovation makes my machine a better option to you for any infant caretaker. Plus other small things like we have in drop-down access panels. If you want to fumigate, just remove these 2 screws. This entire thing comes out. You can just go and fumigate and clean it. Plus another thing is that the baby bed is made transparent from here, so you can even place it under surface phototherapy. And this is a tray where either you can keep an under surface phototherapy, or even you can keep the baby related material or the resuscitation material, whatever as you require. And plus this is another storage that can be, if you need it, can be used. Above all, if you look at this machine, it's absolutely sturdy. Nothing goes wrong with this machine, and we always say minimum 15 years of life for this machine. After warmer, let's go to the conventional phototherapy system. This is known as a double surface phototherapy with a microcontroller based. The beauty again, what's the phototherapy? It's a simple thing, but we have again tried and have done something innovative which can be beneficial for the infant caretaker. For example, like we have added the infant timer systems in this. What do you do in a timer system? You can set the phototherapy dose time for the patient. For example, now I want to give a phototherapy to the baby for say 8 hours. So I can set it by using this up and down keys. It's absolutely simple. You just set the keys. You can set it the dose time from 30 minutes to 24 hours. And once the elapsed time is over, automatically the machine shuts off and it gives you an alarm. Plus, it also indicates you what the tube uses are. Here you have an indication of the change the tubes. Plus, you have again a feed alarm which activates automatically after each 2 hours. Now, this phototherapy comes along with a height adjustment facility. You can just either lower or you can just increase the height of the phototherapy by moving this rod. Right? You can adjust the various incline, adjust various angles. So due to this feature, you can even use this phototherapy along with the open gas system. Plus, you have a very sturdy and detachable baby care trolley. So you can just detach it in this way. It's as simple as that. You can take this phototherapy and bring it to the warmer, next to the warmer. So while the baby is in a warming system, you can either give him an under-surface phototherapy or an overhead phototherapy. I'll just show you how it's done. It's very simple. So this trolley, again coming to the trolley, this is a trolley with a baby area and a drop-down side panels, and this is the under-surface phototherapy, which is detachable. So you can use all these three together in combination to give a double surface high intensity phototherapy to the baby, for a baby who has a very high bilirubin percentage. Or else you can just lift this phototherapy, as you can see it here, you can just lift this phototherapy and keep it below the warmer. I'll just show you. So now you are using a warmer in which the baby is treated for hypothermia, plus you have an under-surface phototherapy. So the bilirubin levels can be also taken care of. Now how does the light goes up? See, this is a transparent baby mattress. If you see, it's a transparent panel through which the rays passes. And here you have just a baby bed. So you do two things now on one machine. You treat the baby suffering from hypothermia, as well as you treat the baby suffering from high bilirubin problems. And that's the beauty of this equipment, my friend. As I've told you, the important thing is the rotating features, the rotating monitor tray, the rotating heater box, the rotating saline stand, the rotating temperature control box with a limited angle, the temperature sensors, the observation lamp, the ceramic quartz heaters, the drop-down acrylic panel, and the sturdy design of the machine. Thank you very much. Hello. In continuation to my last briefing in regards to warmers and phototherapy, now we go towards the Dragonfly, the only high-frequency servo oscillator available in the market. This is a Dragonfly. You can now check the screen. It is incorporated with 386 computers and various intelligent microprocessors that ensures that the set pressures and amplitudes are very precisely maintained. If you have observed, a use of 800 VA UPS is mandatory for this, because as I have explained, it comprises various intelligent microprocessors and a computer itself. So it's a next generation technology that we have incorporated the high frequency. So coming to this high frequency, the Dragonfly is the only servo controlled oscillator in the world. When I say it's the only servo controlled oscillator in the world, it implies certain things. For example, if you have seen a contemporary Sensormedics 31008 oscillator, you would have noticed that if you set the pressure and if you alter the flow, the pressure the pressure either falls or goes up. So the pressure and flow goes hand in hand. If you increase the flow, the pressure also increases. If you reduce the flow, the pressure also reduces. So it's interdependent. Same thing is here. But what happens? As a clinician, if we have designed this equipment considering that the clinician should concentrate only on the patient and not on the machine. So each time if a clinician adjusts the flow, he has to again go and adjust the pressure. Or in case the clinician adjusts the amplitude, again the pressure changes in the sensor matrix 3100A. Why? It's simple. If you increase the, for example, if you increase the amplitude, what happens? The distance traveled by the piston increases. So obviously more gases goes in the lung. So that increases the pressure, as simple as that. Simultaneously, if you increase or reduce the frequency, again the pressure, there is a change in the pressure. For example, if I reduce the frequency from say 10 Hertz to 8 Hertz, so what happens? The time given allocated for inspiration increases. So obviously more volume goes in, so the pressure increases. To circumvent this problem, to overcome this problem, we have made a servo control mechanism in our device. So you have the pressure and the flow, both goes hand in hand. They are not independent as in the sensor matrix 3100A. So what we call it as the handshaking mechanism. If you increase the pressure, automatically the signal is also given to the flow, and the flow automatically join. As I've explained, there are microcontrollers in that, so they talk to each other in their language and adjust and open the orifices accordingly, ensuring that whatever the set pressure is set by the clinician is maintained, irrespective whether you change the amplitude, whether you change the inspiration time, whether you change the delta P, or so. So the basic logic is that we are concerned, we have given more stress on the clinicians, and we feel that the clinician should attend the patient and not the machine. So that's why it's a servo control mechanism. You adjust, you change any parameters like the amplitude, the inspiration time, the frequency, your set mean airway pressure remains the same, and that is servo control mechanism. So that's the beauty of this machine. Now coming to the machine, you can see it's a beautiful 15 inches large TFT screen which indicates you various settings and displays. You have a pressure versus flow waveform here. You have time versus flow, and a pressure versus time versus pressure waveform here. So now operating this Dragonfly is absolutely simple. What all you have to do, you have a feather touch piece set here, and this machine walks with you. For example, now I want to set a mean airway pressure of say 16 centimeters, 15 centimeters. So I just press this mean airway pressure. Now this light has glowed. Simultaneously, the map here, it's flickering. So one can know what parameters you are setting. Now using this up and down keys, you can adjust the mean airway pressure. Once you adjust it, just press enter. Now what happens? Now once you enter it, that means now this value is remembered and memorized by the computer inside. Now you have to set the frequency. Go, press the F key here. Again, an LED indication indicates what in which parameter you are going to set the things. Now the set frequency here is 10. Now I want to increase the frequency to say, for example, I have a newborn baby, a 600 grammer or 700 grammers baby, and I want to set a frequency of say 15 Hertz. So what I do, I again use this up and down keys. Set frequency 15, press enter. Simple. Now I want to set the amplitude or the delta P, the power to the piston. Okay, same thing, press this delta P key, use the up and down keys, press enter. Inspiration time is we can set it to 1:1, an IR ratio of 1:1 or 1:2, or an inspiration time of 33% or 50% of the duty cycle time. What is the duty cycle time? The duty cycle time is the time taken by the piston to move to and fro is the duty cycle time. Okay. Now here you have a certain feature like a body weight. In this equipment, we have two flow sensors incorporated in the machine. The one flow sensor is on the inspirator side, incorporated in this equipment. One flow sensor is at the inspirator limb, and the second flow sensor is at the expirator limb. So it senses the flow, it calculates the flow 200 times per second, and thus it decides and and indicates the tidal volume that is delivered to the patient. And now tidal volume again depends on the patient's body weight. So here you enter the patient's body weight. After setting the amplitude, press enter. Then now you'll notice that the body weight is flickering. Just using this up and down keys again, you set the body weight. So now we are talking about a say 600 gram baby. Okay, so I set an body weight of say 800 gram. Fine. Okay, I just press enter. Now I've set all the parameters. What I've set is the amplitude, I've set the frequency, I have to set the mean air pressure. Inspiration time we have talked that we can set it at 33% of the or 50% of the duty cycle time. So normally the inspiration time is never changed. It's always 33% so that you have an I ratio of 1:2. Now all the parameters are set now. Here you have an air oxygen blender, so you can adjust whatever the FiO2 is required. You can set the FiO2 percentage. Fine. Now this is the inspirator link. It's very simple. This is the inspirator link. This is the expirator link. This is the pressure sensor that goes to the wire piece. Here you have the Fisher and Paykel humidifier. And now for the demonstration purpose, I've used a swine lung. You can see a swine lung here. Now I just press start and you can see how the vibrations are going on, and you can see how the alveolus get recruited. Now, coming back to the screen, you can notice what is tidal volume that's going to the patient. As we all know, the tidal volume delivered on a high frequency is less than or equal to the anatomical dead space volume. Now here you can see what the tidal volume per kg is 1.7 and total tidal volume is 1.5. We have something known as the dCO2 figure. You can notice it here, the dCO2 figure. Now what is dCO2? dCO2 is best described as tidal volume square into frequency. Now this is just an indicative value. This helps the clinician to non-invasively monitor the trends in patient. For example, if I place a baby of 800 grams on high frequency and after 1 hour I take a blood gas. The blood gas is, for example, the PCO2 values are say around about 70 and my DCO is, for example, 40. So what I make a chart, and instead of doing serial blood gases, what I do, I adjust the DCO2. That means I adjust the amplitude. That means I adjust the tidal volume. The tidal volume depends on the amplitude. So if the PCO2 percentage are very high, what I do, I increase the amplitude. Once I increase the amplitude, more tidal volume goes in the patient, more CO2 is washed out, plus simultaneously the DCO2 values goes up. So now here you can formulate a certain chart. If my PCO2 values are so and so and my DCO2 is so and so, what I need is that if I increase the amplitude, my DCO2 also increases, so my PCO2 goes down. So this is a rough guideline to avoid the repetitive blood gas analysis, and that is one of the feature of the Dragonfly. Again, you can notice that the bias flow is automatically adjusted on this. What all I have done is that I have just set the mean air pressure. As explained earlier, the flow and the pressure valve goes hand in hand. They have a handshaking mechanism in them. So they talk to them in the electronic language with them, and they give feedback. So okay, if you are if the flow says the flow says okay, now if you want to achieve a map of 15, I'll open my orifice in such a way that your map is maintained, simultaneously the bias flow is sufficient, and vice versa also. So that's the beauty. So the clinician doesn't need to adjust the bias flow. What all he needs to do is to set the amplitude, the frequency, the map, and the inspiration time. Rest is done all automatic. Plus few more features. Like if you can notice it here is the set map and here is the actual map that is delivered. Now how this map is calculated, I'll just show you. I'll just freeze this graph for you. Now if you see the max, this is the mean air pressure. We have opened up the lungs, kept it open, fine. And now we are imposing vibrations on the mean air pressure. So what is the maximum pressure that is generated during the inspiration phase is sensed and indicated as the maximum pressure or the P max. You can notice it here. The P max here is 18 centimeter of water column. Simultaneously, During the expiratory phase, when the piston comes back, when it sucks the air from the patient's airways, there is a negative pressure created in the airways. So what is the negative pressure? That is again sensed by the pressure sensor, and it's indicated as a P minimum. So here it's 12. So how we calculate the MAP then? So P max plus P minimum. So here is 18 plus 12 is 30, divided by 2 is mean error pressure. So this mean error pressure and this mean error pressure matches in the accuracy of plus minus 1 centimeter per column. And here you have the differential pressure. So that's the true amplitude actually. Now coming to the rest other functionings, as I've shown you, you can freeze the graph for clinical purpose. In case if a clinician needs certain help, or if he or she wishes to know certain settings in a certain parameter, he can go to the help facility by pressing this F1 key. Now you have the entire thing it's a PPT presentation. You have the Dragonfly manual, you have a clinical data, you have an HFOV key factors. So now, okay, I have a manual incorporated in the system. Now I want the clinical data. So I press this F2 key. Now I go, I get all the clinical data. By scrolling this page up and down, you can know a lot, you can know everything about a high frequency ventilator. So you see what are the settings you need to set in an ARDS patient or a diffuse homogeneous disease. And now it's a clinical, it's a proper presentation which explains to you how the high frequency works. We all know that high frequency oxygenation and ventilation are decoupled on the high frequency, which is not possible on a conventional ventilator. So what on a high frequency, ventilation depends on the amplitude, that the power, that's the piston, power given to the piston, and the frequency. Same thing is oxygenation depends on the mean, on the FiO2 and the mean air pressure. Here you have it. It goes so on and so forth. And this is the circuit this is the concept that what we are using. Here we have a piston that's attached to an electromagnet and which is attached to a bellows. So when we change the polarity of the magnet, we have an electromagnetic coil and we have a permanent magnet. We give the current to the electromagnetic coil and change the polarity. And the permanent magnet is connected to a piston, connected to a bellows, which acts as a piston. So when the polarity becomes north-south, the piston gets attracted, the magnets get attracted, so the gas is out. The magnets get attracted, the piston gets pulled, so that's the expiratory phase. When the magnet repels, when there is south-south polarity, the magnet repels, and when the magnet repels, the piston goes forward, and pushes the gases in the patient's lung, and that's the inspiratory phase. So it's a true high-frequency oscillatory ventilator. We know there are various types of high-frequency modalities available in the market, like the high-frequency positive pressure ventilation, in which you just set a rate of say 120 or 150 breaths per minute. So it's around about 2 and 2.5 hertz, and give high airway pressures. But in that case, however, the expiratory phase is passive. So there are chances of barotrauma occurring. So that's not used. Second is the high-frequency flow interrupter, in which the expiratory, you have a bank of solenoid valves placed on the expiratory limb, which chops the expiratory flow at a very high rate and thus creates vibration. And with this vibration are reverberated back to the lungs of the patient, and that's how you get the oscillation. But however, again, the expiratory phase remains passive. The third is the jet ventilator, in which the conventional ventilation breaths are delivered, and in between that, jet pulses are delivered. And the fourth is the most popular. The fourth is the high frequency oscillatory ventilator. So I'm quite proud to present you the high frequency oscillatory ventilator, in which the inspiration, expiration both are active. You can set the mean airway pressure from 4 to 40 centimeter per column. You can set the amplitude from 0 to 100%. That's the power given to the piston to move to and fro. Third is the frequency, which you can set from 5 to 18 hertz. And the inspiration time from 33% to 33% and 50%. That's the, we have an IE ratio of 1:1 and 1:2. It's that simple, my dear. Thank you.
On these. No, the ambidextrous arm.
Yeah. You have this ambidextrous arm, so you can move it in any direction. Plus, you can adjust the height, so it moves vertically. It can come forward or it can go back also.
And those end user advantages that we have, wherein the piston need not be.
Yeah, that's a good question. Actually, if you see, the most popular high frequency still to last few years back was the sensor magnet 3100A. But in that, what you need to do is that you have to adjust the center positioning of the magnet for in various cases. Here, what happens? Once you put up the machine, the piston automatically goes to its resting position. That's at the zero. So you need not adjust the piston positioning, and that's a very big advantage, because if on the sensor medics, if I don't adjust the piston positioning, my volume or my amplitude changes, and that's quite risky. So that's the big advantage here, that the clinician did not adjust anything on a high frequency. What all he has to do is to just set the parameters and lift the job to the machine. The machine will take care of that. And as I've said, the job of a clinician is to look after the patient and not to look after the machine. We have our job, we are looking after our machine, you look after your patient. As simple as that.
This child, 3 days, second day old child, a case of meconium aspiration syndrome, and the child is having severe respiratory distress and very bad lungs, and on conventional ventilation the child did not improve. His saturation never rose more than 85%, even with a FiO2 of 80-90%. So now he is on high frequency ventilator. This HFO manufactured by Shreyash. The name of the is Dragonfly, and it is a fantastic ventilator, and you can see the waveform and the settings which we have done. We started the child on a mean airway pressure which is slightly higher than the child was earlier on a MAP of 7, so we started with 10 actually. We started with 9, and the frequency we kept of 10 and delta P of 10. FiO2 was 60% to start with, and IE ratio was 1:3. And you can see the excellent wriggle the child is having, and the child having an excellent wriggle, the chest movement. He is breathing spontaneously, but you can see the wriggle of the chest, and this is what we want. And as soon as the child is on HFO, high frequency ventilator, and you can see the saturation has shot up to 90%, and the heart rate is stabilized. Initially the child was having a tachycardia, and now the heart rate is stable. The color of the child is good, the perfusion is well maintained, and the child is sleeping. The child has been sedated, but otherwise the child is comfortable.
This is an X-ray of a full-term neonate with meconium aspiration syndrome with pulmonary hypertension. In this case, this much is the cardiomegaly. These are the poorly aerated lungs. I repeat, the aeration is very poor, and lungs are low volume lungs, because of which the baby was put on high frequency oscillator. Next. You can notice that after putting the baby on HFO, that is high frequency oscillator, mainly the aeration of this part of lung has improved within 8 hours. The left lung, which was poorly aerated, collapsed, low volume, before HFO, that is on conventional ventilator, improved very nicely on HFO, with changes in oxygenation and clinical condition of the baby also.